Hello everyone, welcome to the EE200Lab course. We are here to implement and measure the second lab assignment. We will start from the part 1, Thevenin Norton circuits.
Okay, in the lab assignment, it says that I have to use 4 different resistors and load resistor. So I have prepared my resistor boxes here. I will use 10k ohm as the load resistor, and here there are 24k, 27k, 39k, and 47k resistors. Before using them, I need to be sure they are the correct resistors, so I will measure them with multimeter. So firstly, I will turn on the multimeter. Red goes to red, black goes to black. Oh, thank you.
DC power cables here.
Thank you. Okay. Firstly, let's select the 10k ohm and select the resistor measurement. It seems I cannot measure it.
With this configuration, it will be hard.
It's okay. I have measured and it's 10k ohm.
Let me show you. You can, since the resistance values are high, you can use this formation actually. And just,
Yeah, it makes sense because it won't hurt me.
just
And
apply a bit stress in order not to
on the props.
on the
Resistor.
resistor,
Ah,
so
okay.
the resistor should stay there.
Okay.
Otherwise, if you hold it loose, the resistor will go off. Okay.
Okay, thank you. Okay, let's connect it.
This is R1.
No, this is load.
The load. Okay.
The second one is 24k.
Is this R1?
No,
I think R3.
it's the R3.
R3. Yes. Okay. During the implementation here, if you don't have the resistor values in the boxes, you can make a parallel or series connection.
Yeah, that's a very helpful tip actually. Okay, multimeter says it's nearly 24k, so I can use this one. Okay, and next I will connect the R4, which I will use 39k. Yes, it's 39k.
For the low resistance values, you can hold the resistors by hand, but for the higher ones, it's not suggested to use your hands. Hold with
it
your
makes
hands.
sense because I will be parallel to the resistor.
Yes, definitely.
Okay, this goes to here and here. And the next one is R2, which I will use 47k.
We are almost there, I guess.
Yes, here we. Actually, I will hold it just like this. It's kind of easier for me. Yes, it's 47k. And finally R1, which is 27K. Yes, it's nearly 26K, but it's okay, I guess. Okay, I have connected all the resistors, and in the lab assignment it says that now connect the DC power supply and set it to 10 ohm, 10 volt.
Okay, let me use these cables.
Thank you for the cables. Since it says 10 volts, I will use the 25 volt side.
Yes, because in the 6 volt channel you cannot apply 10 volt because it's limited with 6 volts.
Yes, and since it's positive 10 volts, I will use the positive side. And I will turn on the supply. To apply voltage to the breadboard, I will use jumpers for easier connection.
Which side is negative side of the voltage supply in your circuit? Can you show?
In my circuit, this is the negative side. It should be grounded, and this side is the positive side. So
Okay.
I will connect the black cable to this side, since they are connected horizontally, and apply the positive voltage to this side. And now I will go to 25 volt mode and open the output. Now I have to apply 10 volts. I increase the voltage gradually. It's a bit slow.
Just press on the knob. It will be. Let me get it.
Thanks. Okay.
What was the RTM in your calculations?
If I remember correctly, I have found it as 20 ohm.
Okay. Then you can continue to the next step here.
Okay, firstly, I will measure the open circuit voltage. So I connected this probe to voltage port, and I will measure the voltage across here. Oh, sorry. I should measure the voltage. It says 2.7 volts, but I don't think so. It should be higher than 2.7 volt. I think there's a problem here.
Because you didn't disconnect the load. In the Thevenin circuit, you need to exclude the load so that you can find the total open circuit voltage in the circuit. Load is
you're right.
connected after that. So
Yeah, that makes sense. It's
But
not
before-
open connected
before-
right now.
touching the circuit, please make it off.
Yeah, that's right. Okay, firstly, I should have disconnected the load resistance and reopen the output, and then we measure the voltage across these nodes. And yes, it says now 8.2 volts, and that was the voltage that I calculated before, so I think it's all true.
You measured the open circuit voltage, now you can measure the short circuit current.
Okay, since it's short circuits, I have to short circuit the load. I will use a jumper to short it. Now I'm measuring current at DC, and I will touch here and here. But it's too small. It's not even. It's basically zero.
Yes,
There's a
actually.
problem here.
Yes. Even though we assume that this is short circuit, but it has some small resistance in it. But when you make it short circuit here, this doesn't have resistance. So all of the current go over this connection, and from ammeter you don't see anything. So since we assume that this is short, you don't have to use a jumper. Actually, you shouldn't use jumper here.
Okay. So our short circuit connected is
Ammeter is just that.
here.
Yes.
Okay. Thank you. Okay. It should be okay this way, I guess. And it's 0.4 milliampere.
It's 412 microampere.
Yeah. The calculated terminal resistance was around 20k, so I think this current value should be true. Also,
Yes.
my calculated current was similar to this one.
The calculation and measurement are in line.
Yes. And in the next step, I should measure the terminal resistance. To measure the terminal resistance, I now calculate connect the load back.
First, still you don't have to connect load, because in the Thevenin circuit we don't use load. Load is connected to Thevenin circuit, so load is outside the Thevenin circuit. So
okay,
we will not use.
I'll
Again.
take it off. Sorry, my bad. Let's take this off. Let's connect here and go to distance measurement. And measure like this, but it doesn't read any value.
Probably it's applying voltage. That's why we need to kill the sources.
Okay.
We are killing in the calculations, so we need to kill here also.
Okay, so I can press the output off, but should I disconnect these cables and short these two nodes?
Actually, you don't have to. When this device is off, it supplies zero voltage, so which means it's a short circuit. When we kill the voltage sources, we are shorting them. So it's the same thing.
Okay, so let's try again. Yeah, it measures 20k ohm.
It's very close to 20k.
So my initial calculation was correct, and also values get from the open circuit voltage and short circuit current are satisfying the measurements. So I think our setup here is correct.
Well done.
Thank you.
Before going into second part, we should have a tutorial about the function generator and oscilloscope. This device provides both. From this output, you will get the signal. This will be the function generator output. These two are the oscilloscope inputs. So let me open the device. First, I will show you the signal generation part. Then we'll go to the oscilloscope part, signal reading and measuring, and then we'll measure the output of the function generator with the input of the oscilloscope. This is the main menu, and there is a wave generation button here. I will press on it, and here waveform, you can change the waveform type: sine, square, ramp, or triangle, pulse, DC. And you can change the frequency from here. You can increase or decrease with this knob here. you can change the menu settings of the menu settings you see here with this knob here. I am setting my frequency to 10 kilohertz, let's say. Here it says 10 kilohertz, yes. And then you can change amplitude here, but if you going to one setting from another, you need to press the button underneath the setting here. Here is an amplitude. If I want to change the amplitude, I need to press this button. If I want to change the waveform type, here. But I'm changing the amplitude here. I press the button and I'm increasing it to one peak-to-peak voltage. Because it says VPP here. Let me set it. It is one peak, and you can change the offset value here if you want. If you want a sine wave around 1 volt, like your sine wave is from 2 volt to 0 volt, then you can set an offset as 1 volt. Then this is the function generator cable. The red terminal is plus, the black one is minus. So I will connect it to here. Yes. And this is the oscilloscope cable. And this part is the measuring part, this one is the reference part, or this is the ground of the oscilloscope. It is connected. For the oscilloscope part, for the signal measurement part, we will use these buttons, these knobs here. This knob is changing the signal in the y-axis here. If you have two signals, two measurements from the oscilloscopes, green one and yellow one, you can, if you want, you can separate them. Let me open it. You can separate them, or you can make their references at the same level so that you can see on top of each other. So in order to close the one channel, you can press 1 or 2. I'm closing the second one, so I'm pressing the second one. The green one has gone. And then you can increase the signal actual scale by this knob by rotating it in the clockwise direction. You can increase it, the scale, and in the counterclockwise you can decrease it. Here there are two measurements set up, cursor and measurement. Measurement will give you the answer directly. For example, let me connect the function generator to the oscilloscope. Red one goes to the signal reading and black ones connected to black one. Generally in the circuits we are putting black ones, we are connecting black ones to the black ones to another. So okay. Here you can see a sine wave here, but it's not stable. So I'm increasing the amplitude scale in order to see clearly, and also increasing the time division. From here I can change the time division here, but it's not stable again. Then I need to change the trigger value. Here there is a purple line here, or orange line. If it's not touching the signal here, it's not stable. It keeps rolling off. and if it's touching, you can see stable one. And trigger works that way, and you can change the trigger type here. You can again change trigger type to edge, to pulse width, pattern, video, anything. We will use edge one. And you can change the trigger source also. If you select the second one here, it starts to roll off because there is nothing in the second channel. So we are going back to first channel, and then you can change the trigger slope here, rising, falling, alternating. And let's go to measurement part. For measuring, as I said, there are two methods. One is cursor. In cursor, we have x1 and x2, y1 and y2. So, in order, let's say it says that here cursors x1, which means that I am controlling the x1 cursor. See, x1 is moving here, going left. You will control the cursor from this knob here. Let's set to mouse to peak here. We have measured with cursors. Now we will use measure button here. Here you can change the source of the measurement type. Since we don't have the second channel, so we don't see the second source here, so we'll go with the first channel. And you can change the measurement type here, but you can change the measurement setting what you want. Like, let's start with frequency. Since we are applying 10 kilohertz signal here, we measure 10 kilohertz here, and we can cross check it with period measurement. Our period is 100 microsecond, which is in line with the frequency measurement. And then next thing you will use is generally peak-to-peak voltage measurement is 1 volt here, as you can see. That's all. After the tutorial, you can start the second part.
In this part I will connect an resistor and capacitor in series and apply alternative current. For the resistor I will use 10k ohm, and for the capacitor I will use 1 microfarad.
But if you are using the cylindrical capacitors, you should be careful. The longer wire here goes to positive side, and the shorter one goes to the ground side. So since here we are using ground in the other terminal of the resistor, so it should be looking down.
Okay.
So
also there is a minus sign at this side, which is very helpful, I think. So you can connect it like this. Okay. In the next step, it says by using the function generator, apply a 5 volt peak-to-peak square wave. To do so, I will use this tool. I can use the function generator from this output, so I will connect its cable. Can't connect it somehow. Okay. Again, I will use some jumpers. And press waveguide button. Waveform is square. I will select 10 Hz as the frequency, and for the amplitude I will select 5. Okay, it should be set. And now it says measure the V peak to peak and frequency values with the cursors of the oscilloscope. For the measurement, I should connect this probe here. I have to use another jumper. Okay, we'll connect this one to here and this one to here. Now it says play with. Okay, I should play with voltage. It may be too small, so I may not be able to see, but even though I changed the voltage setting,
Actually, first
I
thing,
can't see any voltage.
yeah, if it's too small, you need to change it clockwise. But the main problem is here, you connected to oscilloscope in a wrong way. So since this is ground, you're grounding this your source here. So your polarization is wrong. It should be opposite way.
Okay, so I should connect negative side to the negative side of the circuit.
Yes.
I mean the ground. And then positive side to the positive side.
In circuits, you should connect all of your grounds in the same node. Other way,
Okay, it seems kind of better. I think voltage should be fine. Now I will change with time diff. It says it's at the limit, so I will decrease it. And I can use this node to scroll the voltages upwards, or also I can shift it downwards. And yes, I can see square waves here.
yes, you can scale it a little bit down. So, okay.
Yes, like this. Seems okay. And it says here play with the amplitude and the frequency. Amplitude here. Yes, I have decreased the amplitude to the 2.5 volt peak to peak, and my voltage here is also decreased. But it's not stable, it's shifting backwards. Why does it happen?
Yes, the reason is the trigger. As it's said in the tutorial, the trigger should touch in the screen to your signal here, so that it should be stable.
Oh, okay. Now it's stable.
Yes. The trigger is inside the signal area. That's why.
Okay, I see. So
Now
it should
change
be
the
okay.
frequency.
Okay, I can change the frequency by pressing the frequency button and then increase the frequency from here. I will select 5 kilohertz. Now there is a mess on the screen. I think I should use the time diff to take a closer look. And yes, my square wave is here and it seems okay.
Okay. Measure now. If you want. Or
In the lab manual it says that I should measure the voltage across the
Okay,
capacitor.
then.
So I will take this oscilloscope probe and connect next to the capacitor.
just leave it
Okay, it's okay. Yeah, there's nothing on my screen, weirdly. I think it's too small. But still, there's nothing.
If you read that it's a connection error, then you can use another way to measure it, like just touched here. If you see that it's not a connection error, then why can it be? Let's try another frequencies.
Yeah, actually it makes sense because I have selected 1 microfarad capacitor and I have applied 5 kilohertz. Impedance of this capacitor for this frequency should be too small, so I may not be able to see any voltage. So maybe decreasing the frequency will help. So I decrease it again to 550 hertz, and now I have some waveforms. I can take a closer look. Yes, it's not triggering again, so maybe I should set trigger level for a lower level. Yes, it is a triangle-like.
It seems
waveform.
triangle, but it's because capacitor is charging and it's
I
charging.
have applied square wave. Why is it in the why it's in a triangle way?
Because in this frequency, actually, the capacitor is charging and discharging, and the frequency is still high for the circuit, so it doesn't stay at one level. Before settling it to a level, it's discharging, and before settling a low value, it's charging.
I see. So we can say that capacitor cannot catch up with the voltage across it.
Yes.
So maybe decreasing the frequency will help.
Yeah, you will see again a square wave.
Yes, we can try, I guess. Okay, I have chosen 9 Hz. Since the waveform is too big, I will set the voltage tip again.
And also notice that when you decrease the frequency, the amplitude gets bigger.
Yeah, because of the impedance of the capacitor.
Yeah.
I guess. Yes, now capacitor catch up with the voltage, and waveform is more like square wave.
Yes.
Okay.
Now play with trigger.
Actually, I think trigger is fine right now. So
No.
I should change the trigger type from rising edge trigger to the falling edge trigger. So I press the trigger button, and from here I press the swap. Rising edge is selected here, so I will change it. Yeah, and the waveform on the screen has changed. Oh, I see now. At the middle of the screen there is a rising edge if the rising edge is selected, and when I change it to the falling edge, I see a falling edge.
Yes.
It's quite easy actually. So
Well done. You finished the second part of the lab. See you next week.